Alright, I'm going to talk about congruent triangles and what it means when we have congruent triangles. We want to know kind of what congruent triangles do for us and what it really means if we have congruent triangles before we get into trying to prove that triangles are congruent. So if you have congruent triangles, that means all of the corresponding sides and angles are congruent as well. And corresponding is kind of going to mean the same thing that it meant when we were talking about the corresponding angles on our parallel lines. It means things that are in the same place on the two triangles, they're the ones that are the same. They're the ones that are congruent. So here I've got an example. Okay, these triangles are congruent. So I'm telling you that. So let's say that's a given. That means that things on this triangle, okay, so certain pieces like an angle or a side are going to be congruent to a certain angle or a side over on this triangle. So let's just look at each piece and figure out what it would be congruent to over on here, and then we'll talk about how to write out that these are congruent triangles. So if I look at angle A, okay, that's the two short sides. Where the two shorter sides come together is angle A. Okay, because clearly BC would be the longest side. So where the two shorter sides are coming together, that's angle A. So angle A is going to be congruent to the angle over here where the two shorter sides come together. So that would be angle Y. C is where the shortest side and the longest side meet. So angle C is going to be the same as where the shortest side and the longest side meet here. So angle X. B is where the middle side and long side meet. So B is going to be congruent to W. So that's angles. Now we can look at sides. AC is the shortest side. So that's going to be congruent to the shortest side on the other picture, or on the other triangle. AC, XY. The next longest side is AB. So that's going to be congruent to WY. And BC is the longest side. So that's going to be congruent to WX. So knowing that these triangles are congruent gives me these 6 other congruencies. Now when I go to write that this triangle is congruent to that one, I want to write it in a way that lets people know which angles are the same and which sides are the same. So if they don't have a picture, they'll know which pieces correspond to each other. So when I do that, okay, so triangle ABC is going to be congruent. Now, I need to be specific in the way that I order the letters. So A was the same as Y, so if I list A first, I have to list Y first. B was the same as W, so I have to list W next because I had A, B, C, so I need Y, W, X. A is the same as Y, B is the same as W, C is the same as X. This is the only correct way to say that these triangles are congruent. If you say ABC is congruent to WXY, that's incorrect because you don't have the right pieces matching up to each other. So same thing, if I start with this, I can look and say AB is the first 2 letters, YW are the first 2 letters, so AB should be congruent to WY or YW. BC are the last 2 letters, BC, they should be congruent to WX because they're the last 2 letters. Right. Another theorem we're going to have is the third angles theorem. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are also congruent. This comes from our triangle sum theorem. So let's say I know that this is 100 degrees and this is 100 degrees. And we'll call this 45 and this 45. Well, so I've got two angles here congruent to two angles here. So just knowing that I have to have 180 degrees in this triangle and this triangle, it just follows logically that these last angles are going to have to be the same, because I'm getting 145 degrees. I've only got 35 left. 145, I've only got 35 left. So if I've got two congruent angles, that's enough to say that the third angles are congruent. So, and I'll show you a use of this on the next page. Okay, here's one use of it. This is 87 and 22. Okay, I don't know what this angle is, but these two are congruent to these two. So therefore, I know that this third angle is congruent to this third angle, so I can fill this in and then use my triangle sum theorem to solve this. 4x plus 15 plus 87 plus 22 is going to equal the total 180 degrees. So we get 4x plus, let's see here, we would have 109, 124 equals 180. Subtract 124. So 4x equals, let's see, that'd be 56. Divide by 4, and you get 14. Okay, so that's an application of the third angles theorem. Here, we have to determine if the triangles are congruent, and we don't have any shortcuts for this yet. So right now, I need to make sure that all the sides are congruent, and all the angles are congruent. So I'm given that E is the midpoint of BD. So E is the midpoint of this segment here. So I'm going to mark it as congruent. Notice I'm not using a single dash, because the single dash is already used here. Okay, this length is the same as this length, but this length is not the same as this one. So I need different symbols. I also have some vertical angles here. Okay, these vertical angles, okay, that's one set of angles, and then 95 and 95, that's two sets of angles. So by the third angles theorem, I would know that these are congruent. So I've got all three angles congruent to the other three angles. I've got two sides congruent to two sides. I do not have the last side, and there's no third sides theorem. So right now, I would not know that these are congruent triangles. But let's just say that I was given that these are also congruent. Now I could say they're congruent, and I want to do that by writing a congruency statement with the letters in the proper order. So triangle ABE, the first triangle you can just name any way you want. Okay, that's congruent to, okay, A would correspond to, since A has double curves, C has double curves, C goes first. B is 95, D is 95, so D goes next. E is vertical to the other E, so E would go here. Okay, and that's the order I would have to put them in. Now if I started with different, if I didn't say ABE, so let's say I said BEA, okay, what would that be congruent to over here? So pause it, fill in what you think it is, and then hit play and see what I do. So B is 95, D is 95, E is vertical, E is the other vertical, A is the double curve, C is the other double curve. So BEA would be DEC. And we could do it a different way too. We could say EBA and get a different version that way. Alright, so I'm going to tell you that these two triangles are congruent. I want you to list out which angles are congruent to each other and which sides are congruent to each other. So hit pause, do that, come back and see what the answer is. So angles first. Angle D was listed first, as was angle H, so they're the same. Angle B was the same as angle W. And angle X was the same as angle T. Now let's just say we need to use 3 letters to list angles. Okay, maybe our picture requires us to use 3 angles, or 3 letters. I could still talk about angle D. D is going to be the vertex of my angle. So I could say angle BDX. Okay, D has to be the middle because it's the vertex. And that would be the same as, so BDX, I want WHT. So that's how you do it with 3 letters. So these are my angles, or I could go through with a 3-letter version. Now let's talk about sides. DB, the first 2 letters. Oops. DB will be congruent to the first 2 letters here. HW. BX, the last 2 letters, will be the same as WT, the last 2 letters here. And then we've got DX, the first and third, congruent to HT, the first and third. Okay, so that gives us an intro to congruent triangles. And next lesson will be on shortcuts. We'll start looking at shortcuts to prove that triangles are congruent.